Hey everyone, it's Ms. Joyce. Today we'll be reviewing for the Module 2 assessment. Let's start with 2,535 divided by 11. First, on the inside of our division symbol, we're going to place the dividend 2,535. On the outside, we'll place our divisor 11. Let's list those multiples of 11 since the 11 is our divisor. We have 11, 22, 33, 44, 55, 66, 77, 88, and 99. Let's look at the biggest place value, and this number is the thousands place. There are 2 thousands. So we're going to look at our multiples of 11 to see which gets us closest to 2 without going over. Well, if we look at the first multiple 11, we get 11. That's already too big. So since the first multiple is already too big, we're going to place a 0 up here in the ones place to show that we're going to give each group 0 thousands. So if we're giving each group 0 thousands, we're sharing a total of 0 thousands. So we can subtract the 2 thousands that we have minus 0 thousands we're sharing to show that we still have 2 thousands left to share. We can rewrite this as hundreds by bringing down the next digit, which is the 5 in the hundreds place. So now we have 25 hundreds. If we look at our multiples of 11, we're looking for the multiple that gets us closest to 25 without going over. Well, the second multiple gets us to 22. So this gets us as close to 25 without going over. This tells us that we're going to put 2 hundreds in each group. So in the hundreds place, we're going to put a 2. So if we're placing 2 hundreds in each group, and there's 11 groups, we're going to share a total of 22 hundreds. So we can subtract the 25 hundreds we have minus the 22 hundreds we're sharing to get 3 hundreds left over. We can rewrite this hundreds as tens by bringing down the next digit, which is the 3 in the tens place. Now we have 33 tens. Let's look to see which multiple of 11 gets us closest to 33 without going over. Well, the third multiple of 11 gets us exactly 33. So that means we're going to place 3 tens in each group. So we're going to put a 3 in the tens place. 3 tens in each group times 11 groups gets us a total of 33 tens that we're sharing. So if we subtract, we had 33 tens, we shared all 33 tens of them, there are 0 tens left to share. Let's bring down the next digit, which is the 5 in the ones place. So we have 5 ones to share. Well, if we look at our multiples of 11, the first multiple is already too big. We don't have 11 ones to share. So that means we're going to place 0 ones into each group. So if we're giving each group 0 ones, that means we're sharing a total of 0 ones altogether. So when we subtract 5 ones minus 0 ones that we're sharing, we still have 5 ones left over. Since there are no other digits to bring down, our remainder is going to be 5. So the quotient, or answer, is 230, remainder 5. Now let's try decimal division. Simon says that 16 divided by 5 equals 13 divided by 4 because both answers are 3 remainder 1. Show his mistake using decimal division. Let's start with dividing 16 divided by 5. On the inside of our symbol, we're going to put 16, which is our dividend, and on the outside, we'll put our divisor 5. If we look at the biggest place value, which is the tens place, we see there's 110. Well, there's nothing we can multiply by 5 to get closest to 1 without going over. So we're going to place a 0 up here in the tens place, showing we're sharing 0 tens between each group. So if we're giving each group 0 tens, we're going to share a total of 0 tens altogether. So if we have 110, we're sharing 0 of them, we still have 110 left to share. We can rewrite this as ones by bringing down the next digit, which is the 6 in the tens place. Now we have 16 ones. So we're asking ourselves, what can we multiply by 5 to get closest to 16 without going over? Well, 3 times 5 gets us closest to 16. 3 ones in each group times 5 groups means that we're sharing 15 ones. So when we subtract the 16 ones we have, we're sharing 15 of them, we still have 1 left to share. This is how we're getting 3 remainder 1. But we can rewrite this as a decimal. Since there's no other numbers to bring down, we can place a 0 in the tens place since there are no tenths. Remember to put the decimal between the ones and the tens place. So if we bring down that 0, we can rewrite that 1 as 10 tenths. So now we're asking ourselves, what can we multiply by 5 to get closest to 10 without going over? Well, 2 times 5 gets us exactly 10. So that means we're going to give each group 2 tenths. So 2 times 5 gets us 10. So that means we're sharing a total of 10 tenths. When we subtract 10 minus 10, we get 0 left over. Now that we're at 0, we are done dividing. So another way we could write 3 remainder 1 is 3 and 2 tenths. Let's do the same for 13 divided by 4. Inside our division symbol, we'll place our dividend, 13, and on the outside, we'll place our divisor, 4. We're going to start by sharing the biggest place value, which is the tens. We have 110. Well, there's nothing we can multiply by 4 to get closest to 1 without going over. So we're going to place a 0 up here in the tens place. 0 tens in each group times 4 groups means we're sharing a total of 0 tens. 1 minus 0 is 1. We can bring down the next digit, which would be the 3 in the ones place. So now we have 13 ones. So we're going to ask ourselves, what can we multiply by 4 to get closest to 13 without going over? Well, 3 times 4 gets us closest to 13. So we're giving each group 3 ones, and there are 4 groups. So 3 times 4 gets us 12. So we're going to be subtracting 12 ones we're going to share all together. So if we had 13 ones, we're sharing 12 of them, we still have 1 left over. So this is how we're getting 3 remainder 1. But we can rewrite this remainder as a decimal by bringing down the next digit. Since there are no digits here, we can write that there are 0 tenths. So remember, the decimal point always goes between the ones and the tenths place. Let's bring down the 0 tenths to rewrite 1 as 10 tenths. Now let's ask ourselves, what can we multiply by 4 to get closest to 10 without going over? Well, 2 times 4 gets us 8. So that's as close as we can get to 10 without going over. When we subtract 10 minus 8, we get 2 tenths left over. So let's keep dividing. Notice there are no other digits to bring down, so we can write this as having 0 hundredths since there are no hundredths there. So let's bring down that 0 in the hundredths place to rewrite 2 tenths as 20 hundredths. So now we're going to ask ourselves, what can we multiply by 4 to get closest to 20 without going over? Well, 5 times 4 gets us exactly 20. So if we have 20 hundredths and we're going to share all 20 hundredths, that means we have 0 hundredths left over. Since we're at 0, we know we are done dividing. So 3 remainder 1 in this problem can be rewritten as 3 and 25 hundredths. So to answer the question or show the mistake, both answers are 3 remainder 1, but 16 divided by 5 equals 3 and 2 tenths, while 13 divided by 4 equals 3 and 25 hundredths. Now let's try some numerical expressions. Here we have 5 times the sum of 40 and 10. We're going to write this as a numerical expression, which just means we're using numbers and operations. Let's start with the beginning. 5 times means we're multiplying 5 times the number. The sum means we're going to be adding, but remember the sum is the answer to an addition problem. So we're going to be adding 40 and 10, but in order to multiply 5 times the answer to 40 plus 10, we need to put 40 plus 10 in parentheses. That means we'll solve this part first and then multiply our answer times 5. So let's find the expression. The expression is just the answer. Find the value. So the value is just the answer. First, we need to solve what is ever inside the grouping symbols. 40 plus 10 is 50. And now we can multiply our answer 50 times 5. So 5 times 50 is 250. Let's try another one. the difference between 5 threes and 2 threes. Well, the difference means that we're going to be subtracting. We are going to be subtracting 5 threes, which means 5 groups of 3. Well, we can write 5 groups of 3 by 5 times 3. We're going to be subtracting the answer to 5 times 3 by the answer to 2 groups of 3 or 2 threes. Well, 2 groups of 3 is 2 times 3. So we're going to be finding the answers to both of these multiplication parts first and then subtracting those two answers. Remember, in GEMS, multiplication and division becomes before subtraction. So that's why we're going to solve the multiplication parts first. 5 times 3 is 15, and 2 times 3 is 6. So now we can subtract 15 minus 6, which equals 9. So the value of this expression is 9. Now let's rewrite this numerical expression in words. Well, first it says that we're going to be multiplying 2 times the answer to 16 and 4. Another way to say that we're going to be multiplying 2 times something is by writing 2 times. Now remember, the answer to an addition problem can be written as the sum. So we're going to be multiplying 2 by the answer to the addition problem. And in the addition problem, we're going to be adding 16 and 4. So we have 2 times the sum of 16 and 4. When we find the value or the answer, we're going to start by solving what is ever inside the grouping symbols first. 16 plus 4 equals 20. And now we can multiply that answer 20 by 2. So 2 times 20 gets us 40. The value of this expression is 40. So now let's rewrite this numerical expression in words. Here we are doing 15 divided by 3 and then subtracting 4. Well, the word we can use to show that we're getting the answer to a division problem is using the word quotient. So we're going to be finding the quotient or answer to a division problem, and the two numbers we're dividing are 15 and 3. After we find the answer, we're going to be subtracting 4. Another way to say that we're going to be subtracting 4 is by saying minus 4. So the quotient of 15 and 3 minus 4. When we solve this, we're first going to be solving whatever inside the grouping symbols first. 15 divided by 3 is 5, and then we'll subtract 4. So we have 5 minus 4, which equals 1. Now let's multiply 325 by 142. First, we're going to place the factors vertically, which means one on top of the other. We're going to start by multiplying the digits on top by the 2 since the 2's in the ones place. First, we'll multiply 2 times 5, which gets us 10. So the 0 goes in the ones place, and the 1 is regrouped to the top of the tens place. Now we'll multiply 2 times 2, which is 4, plus the 1 we regrouped is 5. Now we can multiply 2 by 3, since the 3 is in the hundreds place. 2 times 3 is 6. Notice that for each of these times that we multiplied, we always multiplied by the 2, since that's in the ones place, and we first multiplied by the ones, then the tens, then the hundreds. We're going to do the same order, then multiplying by the 4 in the tens, and then multiplying by the 1 in the hundreds. So the answer 650 is the result of multiplying 325 times 2. Now we're going to multiply 325 times 4, but it's not just 4, the 4 is in the tens place, so it's really 325 times 40. So since this 4 is in the tens place, we're going to place a 0 in the ones place, so our answer will start in the tens place. First, let's multiply 4 times 5, which is 20. So the 0 goes in the tens place, regroup the 2 to the top of the next digit we're going to multiply. Now we'll multiply 4 times 2, which is 8, plus the 2 we regrouped is 10. So place a 0 down here in the hundreds place, regroup the 1 on top of the next digit that we're going to multiply. Now we'll multiply 4 times 3, which is 12, plus the 1 we regrouped is 13. So when we multiply 325 times 40, we get 13,000. Now we're going to multiply 325 times 100. Since the 1 is in the hundreds place, we're going to place a 0 in the ones and the tens place, so our answer will start in the hundreds place. First, we'll multiply 1 times 5, which is 5. Then we'll multiply 1 times 2, which is 2, and 1 times 3, which is 3. So this answer, 32,500, is from multiplying 325 times 100. Now we're going to add all these products up to get our final product. 0 plus 0 plus 0 is 0. 5 plus 0 plus 0 is 5. 6 plus 0 is 6. Plus 5 is 11. So place the 1 down here in the hundreds. Regroup the 1 to the thousands place. 1 plus 3 is 4. Plus 2 is 6. And 1 plus 3 is 4. So our product, or answer to the multiplication problem, is 46,150.